Hi ho, hi ho. It's off to chapter 10, lesson 2 we go. All right, kids, here we go. Chapter 10, lesson 2, all about histograms. Histograms. So, in our books, we should be on page 442. Our learning target today is going to say, I can construct and interpret a histogram. So, let's start off with that in our notes. I can construct and interpret histograms. So today is another new graph. Last time we talked about stem and leaf plots. Today we are focusing on a new one called histogram. So we'll start off with that word. Histogram. What the heck is a histogram? Okay, so last time our stem and leaf plot had this weird line down the middle. We had some numbers on the left, some numbers on the right. Histograms look very different. At the top of page 442, you'll see in the key idea box what a histogram looks like. And in that box, it says a histogram is a bar graph or type of bar graph that shows the frequency of data values in intervals of the same size. So it's like a bar graph. So we'll write that down, like a bar graph. We're going to say, but it shows frequencies of data values in intervals. So here's an example of an interval. An interval would be something like from 2 to 10. 2 to 10 is an interval because it goes from one number all the way to a different number that's not right next to it. You could say the weather outside is going to be 60 degrees to 65 degrees. 60 to 65 is an interval, okay? So it could be in between there as well. Also, it says the height of a bar represents the frequency of the values in the interval. So it has an example sitting there for us of CDs owned. And if you look at that example, you can see that from 0 to 9, how many CDs are there? 0 CDs to 9 CDs. 4 people own 0 to 9 CDs. 10 to 19, looks like the bar goes up to the 3. That means 3 people own 10 to 19 CDs. 20 to 29, only 1 person owns that many. And then 30 to 39, you can see that 2 people own that many CDs. Now we're talking about CDs, which is super old school, right? Now no one has CDs anymore. But here we go. We are going to make some to get you to understand this a little bit better. Now what I have done here is I have found this in our book for you. So here's example 1. So if you look at here, you can see what exactly I'm looking at in your book. Might make it a little easier to talk about. Here's the CDs that I was discussing. So there are 4 people that own from 0 to 9 CDs, 3 people that own 10 to 19 CDs, only 1 person that owns 20 to 29, 2 people that own 30 to 39, somewhere in that range. So let's go to example 1. Making a histogram. The frequency table shows the number of laps that people in a swimming class completed today. Display the data in a histogram. So we're going to take this table, jot it down in our notes, and then we're going to make a histogram out of it. So it kind of gives us the end here, but we're going to be going through that process to make it. So let's go back to our notes here. This is going to be example 1, so we'll switch colors. We'll go with pink first. Love pink. Example 1. Okay, we are going to make a histogram. That's our directions today. For example 1, make a histograms. That doesn't make any sense. Get rid of the S. There we go. Okay, so the table they give us is talking about number of laps. And the other side of the table, I'm just going to make a little T-chart here. Kind of starts out by looking like a stem and leaf plot, but frequency is over here. This is data that they have collected and they've given us. So 1 to 3 laps, how many people did 1 to 3 laps? It says 11 people did that. And 4 to 6 laps, it tells us that 4 people did that. Then we have 7 to 9 laps. The chart says there are 0 people that did that. Then there are 10 to 12 laps. And we have 3 people that did that. And then we have 13 to 15 laps. And it tells us that there are 6 people that did that. If I can find my pen here. Where is my pen? There he is. 6 people that did that. Let's scroll down here. That is our chart. Now we're going to make a histogram of it. So our histogram starts out with an x-axis and a y-axis. So we're going to draw a line down and we're going to draw a line over. Okay, so we're going to label each axis. Now here we're going to do frequency. So we're going to spell out frequency sideways, kind of labeling up the side here. And then down at the bottom, we're going to put our number of laps. So number of laps. Okay, now if we look at our frequency, we have to get all the way up to 11. That's the highest frequency. So we have to label this side of our graph so that we can get to 11. This is going to be a 0 down here. If we went by ones, we would only have 1, 2, 3, 4, 5. That wouldn't work. If we went by twos, we would have 2, 4, 6, 8, 10. Ugh, we're still not there. So let's label by threes. Let's go 3, 6, 9, 12. And we're going to get up to 11 finally, aren't we? 15. We don't really need a 15, but we can put it on there anyway. So this first frequency is going to be 1 to 3, and we'll use 2 kind of chunks here for our bar. So the 1 to 3 laps was our 11. So we're going to make a bar going up to the 11. Here's the 9. Here's the 12. Right in the middle would probably be, I don't know, 10 and a half. So 11 will be right underneath the 12. So we're going to make a bar going to the 11. And here is my 1 to 3 frequency bar, 11 people. The next frequency is 4 to 6. So we'll use this one, 4 to 6. And 4 people did that. So here's my 3, here's my 6. 4.5 would be the middle. So let's go right above the 3 to represent 4 people did 4 to 6 laps. There's that bar. The next frequency is 7 to 9. And nobody did that. So we're not even going to have a bar at all there. 10 to 12 is our next one. And 3 people did that. So we're going to have a bar going up to the 3. Oops, wrong spot. Here's a bar showing that 3 people had 10 to 12 laps. And the last frequency is interval, I should be saying, 13 to 15 is 6 people. So we're going to have a bar going to the 6. Whoa, that was a squiggly line. So there are my frequency bars and interval bars. There is our histogram. So this is our laps completed. We can title it too. That's what our data was taken a look at. So we just took a table and we made a histogram out of it. Notice that that's a little bit similar to a bar graph where it has bars, but the side is always going to be the frequency on a histogram. The bottom is always going to have intervals like 1 to 3 and 4 to 6. It's not going to just have one thing underneath. That's the kind of the difference between just a regular bar graph and a histogram. So go ahead and pause the video and try it on your number 1 if you would like to get a little extra practice on making histograms on the bottom of page 442. If you tried that out, can't really show you what it should look like, but I can talk you through it. You should have a bar for the 10 to 19 interval going up to the 16. You should have a bar for the 20 to 29 going up to the 11. For the 30 to 39, the bar should be going up to the 5. From 40 to 49, bar should go up to the 2. From 50 to 59, bar should be going up to the 4. Kind of hard to talk through that, but it's kind of what we got to do. Now, for example number 2, we are actually not really going to write anything for example 2 besides a couple of the answers. I don't want to have you or make you write every single histogram down because it does take a while to jot those down. So instead, I'm just going to have us look at our book. If it's not sitting in front of you, you can look here because I'm going to scroll. And this is example 2. It says using a histogram. The histogram shows the winning speeds at the Daytona 500. Question A, which interval contains the most data values? Question B, how many of the winning speeds are less than 140 miles per hour? And question C, how many of the winning speeds are at least 160 miles per hour? So we have 3 questions to answer based upon this histogram. So going back to our notes, we can set those up by talking about the Daytona 500. So we're going to say Daytona 500 histogram. And even though we are not going to draw the histogram, hopefully that will jog our memories as to what we were looking at from our book. So question A asked us, which interval contains the most data values? So back to our notes, we're going to say which interval had most values. That's the question. Let's go ahead and take a look at our book for our answer. Well, you can clearly see that this bar right here is the tallest. It is going to have the most data values in it. So that interval is 150 to 159. So that's what we'll put down for our answer. 150 to 159 was the interval that had the most values. Question B, back to our book. It says, how many of the winning speeds are less than 140 miles per hour? So let's jot that down in our notes. How many speeds are less than 140 miles per hour? Well, let's take a quick look at our book and see. Less than 140. Well, this bar represents 140 to 149. So anything less down here would be less than 140. So if you can see, this bar goes up to the 4. And this bar here looks like it goes up to the 1. So we have 4 right here plus 1 right here that are less than 140 miles per hour. So 4 plus 1 would give us 5. So we can go back to our notes and say that 5 speeds or cars were less than 140 miles per hour. And we have one more question to answer for this example. Question C says, how many of the winning speeds are at least 160 miles per hour? So let's jot that down. How many speeds are at least, meaning bigger or equal to 160 miles per hour? So now we're looking to find 160 and anything that's higher than that as well. So here's 159 right here, this bar. So 160 and bigger would be anything from here on up to the right. This bar looks like it goes up to the 7. So the top line would be 8. That looks like about 7 there. This one looks like it's right on the 4. So we have 7 plus 4 more. Actually, if you look really close to that one, I would say it's bigger than this. I would say 5 there. So let's go 7 plus 5. So 7 plus 5 would be 12. So in our notes, we will say that there were 12 speeds that were higher or equal to 160 miles per hour. And that is us interpreting or using a histogram. If you'd like to pause, at the bottom of page 443, you'll see on your own number 2. All right, if you tried on your own number 2, question A should be 11 students, and question B should be 18 students. Let's go ahead and switch colors. Look at example 3. We're going to do that similarly to the last one, where we're not going to write everything down into our notes. We're just going to jot down what we need. So we'll write example 3. And we'll go ahead and look at the book to analyze what we're going to do here. Here's example 3. It says comparing data displays. If you notice here, this side has a histogram, and this side has a pie chart or circle graph. It says the data displays show how many push-ups students in a class completed for a physical fitness test. Which data display can you use to find how many students are in the class? And explain. So if I want to know how many total students are in the class, I need to actually have a number of students for each section. Now, if we look at this, these are percentages. So this little piece is 4%, 24%, 40%, 20%, 12%. Those percentages give us 100% of the kids, okay? But if we look at the histogram, this side actually gives us the number of students. So if this bar goes up to 3, we know there's 3 students there. We know this one goes up to the 5, so there's 5 more students there. This one goes up to the 10, so 10 more. The histogram here would actually be able to give us the total number of students in the class, whereas the pie or circle graph only gives us percents, and that would not give us how many total kids are in the class. So in our notes, we're going to write comparing data displays and question asks us, which graph tells you how many students total? And we will write our answer to that. Histograms can tell you totals. All we have to do is just look at the frequencies on the left. And that will total up how many total people we have in the class. Okay, we have one more example. So let's go ahead and look back at our book. And example 4 is a multiple choice question. Making conclusions from data displays. It says, which statement cannot be made using the data displays in question 3? So if we look back up in question 3, we're looking for one that cannot be answered. 12% of the class completed less than 10 push-ups. Okay, less than 10 push-ups. Well, if I'm looking at percentages, I probably want to look at this one right here. So we're looking at 12%. Here's 12% of the class completed less than 10 push-ups. Well, 12%, this is less than 10. I think that's a true statement. 5 students completed at least 10 and at most 19. So 10 to 19. 10 to 19 is right here on a histogram. And it looks like there were 5 students. So that's going to be a true statement. At least one student completed more than 39 push-ups. Well, here's 39 push-ups right here. We know at least one student right here completed more than that. Okay, and the last statement says 29% of the class completed 30 or more push-ups. Okay, well, 29% completed 30 or more push-ups. Let's see, where's 30 or more? Here's 30, and here's the more. So we have 24% and 4%. If we added those percentages together, that would get us 28%, would not get us 29%. So D is what we would choose for cannot be made. We don't really necessarily have to write that one down in our notes since it's just a multiple choice. But if you'd like to pause and try number 3 and 4 on your own, you can do that now. Okay, if you answered number 3, the answer should have been the circle graph. And an example you could have said, for example 4, there's lots of different answers, but a sample answer would be something like 16 students completed 20 to 39 push-ups, or 88% of the class completed 10 or more push-ups. Something like that could be your answer. And that brings us to the end of our second lesson in Chapter 10.